Hey, welcome back to Mr. P Helps with Algebra. This is Unit 4, Topic 3, Lesson 1, and we are going to be solving quadratic equations in this topic, starting on a new topic. And we're starting off with a warm-up which has factoring. So some stuff we've done in the last topic. In this first problem, we're going to factor out the GCF of this binomial. Both of these terms can both be divided by 4, and they both have at least one x. So I take that 4x, which is the GCF, and I factor it out. This divided by 4x is x. This divided by 4x, well, negative 12 divided by 4 is negative 3, and x divided by x is itself. For the next question, it's a trinomial, and we're going to figure out what two numbers have a product of c, but also have a sum of b. So negative 36, all the factors of 36, so 1 times 36, or 2 times 18, or 3 times 12, and 4 times 9, which happens to be the one that we're looking for, so I'll stop right there. Looks like the 9 has to be the negative because the b term is negative. So whichever one is bigger has to be the negative because this is negative. If it was positive, it would have been the other way around. So it's going to be x minus 9 times x plus 4. All right, over here we got a leading coefficient. 2 times 7 is 14. Multiply your a times c. Figure out, well, hey, what is the split? What are all the factors at 14? That gives me 1 and 14, 2 and 7. Which one of those sets of factors is going to add up to b? If none of these work, then it's not factorable, but 7 plus 2 is 9. So what I'm going to do is I'm going to write it as if there was no leading coefficient. I'm going to write x plus 2 times x plus 7, like those were the factors. And then I'm going to divide both of the factors by 2. And once I do that, x plus 1 is 1 factor, because 2 divided by 2 is 1. And 7 can't be divided by 2 not to get a whole number at least. So when you can't get a whole number, then that becomes the coefficient of that factor. So 2x plus 7 is the other factor. And there's your answers. All right, so as I mentioned before, we are going to solve quadratic equations. We're going to do it 4 different ways in this topic. And this happens to be the zero product property. Zero product property simply states that anything times 0 is 0. All right, so we're going to start off with creating a table using this equation, x minus 4 times x plus 1. If you put that in your graphic calculator, you are going to get a function. I'm going to create the table right here. Negative 6 is in between, then it goes negative 4, if my memory serves me right. Then it's going to be 0, and then 6 here. So I decided to put... the vertex would be 1.5, because I believe this is 1 and then 2. So negative 3 times 2 is negative 6. Yeah. 1, 2, 3, 4, 5. 0, negative 1, negative 2. So this is what the calculator would tell you when you put it into the calculator and look at the table. 1.5 is the vertex because it's in between 1 and 2. We don't have a vertex on this table. That's okay. So when I'm going to graph it, and I'm just going to do a rough sketch right here. So that's going to be 1, negative 6, 1, 2, 3, 4, 5, 6, and also 2, negative 6 down here. Next one's going to be negative 4, and then 0. All right, so it looks like our equation is going to look something like this. Sorry, it's not perfect. Find x. So what would x have to be in this equation to equal negative 6? Well, there's actually two answers, 1 and 2, because when you look at the table, 1 and 2 both have an answer of negative 6. 0 and 3 are the two times when negative 4 is the answer. And then, let's see, negative 1 and 4. And then negative 2 and 5 are when it equals 6. Now, these are the two x-intercepts. And those are the two places where it hits the x-axis. That'll be important because whenever you set something equal to 0, the x-intercepts become the answer. Compare the equation table graphing the value of x to the equation. What connections can be made? Well, they're all given all the exact same information. What you might not have noticed is that all of these pairs all add up to 3. So because they're both on opposite sides of the parabola. What is interesting about x minus 4 times x plus 1 equals 0 in comparison to the equation? So I think I already answered that because when you set the equation equal to 0, whatever's an x-intercept is the solution. Now, these are all ways of finding the answers. This is the answer to this is the answer to this, and this, and this, and this. So what we notice is that whenever you change the answer here, you get two different resulting answers to the question. So if you change so the equation is set equal to a different amount, you're going to get different answers. I guess that's a better way of putting that. So what is zero product property, and how are we going to use that to our advantage? So anything times 0 is 0, as I mentioned before. So if we have two factors, we're given factored form of the equation. We're set it equal to 0. If this factor, it could be x minus 3. It doesn't matter what it is. If this factor is 0, then it doesn't matter what this ends up being, because 0 times anything is 0. Same thing goes for this one. If I can make this term 0, it doesn't matter what this is. Anything times 0 is also 0. So there's two answers there. So that's the only number that would work is 0, because you can't do that with any other number. You can't say that with 1 or 2 or 3 or 4 or 5. Only 0 has the zero product property. All right, so that basically means that there's going to be two answers. Then all we have to do is figure out what would make that factor 0, and that's an answer. Because whatever makes this factor 0 is an answer, because anything times 0 is 0. It would not matter what this ends up being using that same x value. All right, so I'm going to show you what I'm talking about here. So I'm going to set each factor equal to 0. This is already in factored form, so it's already set equal to 0. So everything's already been done for us. So then subtract 14 from both sides, you can get x equals negative 14. Add 9 to both sides, you can get positive 9. Now question number 5 is a little bit different, because number 5 is in standard form, as you probably know. So the first thing I want to do is change it to factored form. I ask myself, what two numbers give me negative 56 and add up to 1? So that would be positive 8 and negative 7. Okay, once I've done that, now I'm ready to set each factor equal to 0 and solve. All right, so it looks like I subtract 8 here, and that's going to give me negative 8 on this side. Add 7 on both sides using the addition property of equality, and that's going to give me positive 7. All right, this one's just like question number 4. It's already set equal to 0, and it's already in factored form. So I'm going to find out, what does it take to make this parentheses 0, or this factor 0? And it looks like it takes 24, because 24 minus 24 would be 0. 24 minus 37 is a number. I'm not even going to say the answer, because it really doesn't matter, because 0 times anything is 0. X minus 37 equals 0, so that means the answer here is 37. Now you might be thinking, why am I solving it? Why don't I just say it's the opposite of whatever number's there? Because you can't. That's not always true, especially when there's a leading coefficient in front of the x. All right, so we have two issues on question number 7. We have, first issue is the fact that it's not set equal to 0. So that is actually the first step. You always want to set the problem equal to 0 first. So I'm going to subtract 5 here using the subtraction property equality, and then I have to subtract the 5 from the constant. Can't subtract it from the x term or the x squared term, because you can only combine, add or subtract things when they're the same type, same variable. Same variable with the same exponent. They have to be like terms is what we call it. 29 minus 5 is 24 equals 0. Now we've got standard form, so we've got to change that to factored form. So two numbers that equal 24 and add up to 10 would be 6 and 4. X plus 6 times x plus 4. And now I can set each factor equal to 0 and solve. X plus 6 equals 0. X plus 4 equals 0. All right, and subtract 4 from both sides, you can get x is negative 4 over here. Subtract 6 over here, and you get negative 6. So negative 6 and negative 4 are the two solutions. All right, so now this one's a lot like questions 4 and 6. The answers here, yes, they will end up being negative 78 and negative 103. I'm not going to go through that one. For question number 9, you have to set it equal to 0. Add 4 to both sides. That gives you x squared minus 11x plus 18 equals 0. And then what I would do next is I would then factor it. Think about what numbers give you 18 as a factor, but also add up to negative 11. And that would be x minus 2 times x minus 9. Double check that. Negative 2 times negative 9 is 18, and negative 2 plus negative 9 is negative 11. So it looks like the two answers here are going to be x equals 2 and x equals 9. All right, this one looks a little bit different, but it's actually just as easy. This is already in factored form. I know the x out on the outside is in parentheses, but you could put it in parentheses. It's like x minus 0 on the outside. So if it helps you understand, just put it in parentheses. So that's x equals 0 on the left side, which that's already done. That's the answer. And x plus 12 equals 0. So x would be negative 12 and 0. All right, this one, it looks like we got to subtract x squared to set it equal to 0, which is great because that's going to get rid of our leading coefficient on the x squared. So So that leaves us with x squared minus 2x minus 35 equals 0. What two numbers give you negative 35 and add up to negative 2? That would be x minus 7 times x plus 5. Now set each one of these factors equal to 0. And you get an answer of 7 and negative 5. Alright, so let's take a look at the homework. The homework looks like some more factoring. Factor if needed. Alright, so it looks a lot like the questions we had just done. So first thing I'm going to do is set it equal to 0. It's already equal to 0, sorry. Set each factor equal to 0. X minus 22 equals 0. So x over here is negative 17 and x over here is positive 22. This one looks like it needs to be factored, so I think about it. What gives me negative 54 and adds up to 3? It's got to be numbers that are only 3 apart from each other. 9 times 6 is 54, and it looks like the 9 has to be positive because it's adding up to a positive number. Multiply them, you get negative 54. Add them, you do get positive 3. So split the problem in half. Set each factor equal to 0. Subtract 9 from both sides. Looks like negative 9 is the answer here, and 6 is going to be the answer on this side. This one looks like it also needs to be factored. So what two numbers give me 12 but also add up to 8? So that would be 4 times 3 wouldn't work. That would be 7. 6 times 2 gives me 12, and 6 plus 2 is 8. So that's x plus 6 times x plus 2. Set each factor equal to 0. X plus 6 equals 0, and x plus 2 equals 0. And it looks like we're going to get an answer of negative 6 and negative 2. All right, first thing I need to do here is set the problem equal to 0. So that gives me x squared minus 11x plus 20, what is that, 4? What gives you 24 and adds up to negative 11? Well, it's not 6 and 4 because that won't add up to negative 11. It's 8 and 3. So it looks like it's x minus 8 times x minus 3. And then I can set each factor equal to 0. X minus 8 equals 0 and x minus 3 equals 0. So it gives me an answer of 8 and positive 3. All right, I'm going to erase all those and start down here. This question looks like a lot like the one I had just done on the previous page. X is one of this is already in factored form. So x is 0. That's this one. Set that factor equal to 0. That's done. There's nothing to do there. And then 5x plus 4 equals 0. Okay, so finally we got something a little bit different. You can't just say the answer is negative 4. We actually have to solve it. So we subtract 4 from both sides. That gives me 5x equals negative 4. Subtract 4 makes this nothing. Subtract 4 makes this negative 4. Divide both sides by 5. And it looks like the answer is negative 4/5, which is negative 0.8 if you change that to a decimal. All right, this one over here, looks like we got some moving to do. So you have to move the minus 2x squared right here. Subtract 8 here, and that gives us x squared plus 2x. The x's didn't change. And negative 40 minus 8 more makes negative 48. All right, we want two numbers to give you negative 48, but also add up to positive 2. So it's not going to be 12 times 4. What else goes? 6 times 8 goes into 48. So it looks like it's going to be x plus 8 times x minus 6. And once again, 8 times negative 6 is negative 48. Check. And 8 plus negative 6 is positive 2. Check. Now I can split it in half and solve it on both sides. And I'm going to get an answer of negative 8 and positive 6. All right. Please give it a like if it helped you learn something about using zero product property in order to solve quadratic equations. And definitely subscribe if you haven't done so already. Thanks again for watching. Have a great day.